Good morning, friends. Lecture 3, and we are going to discuss today interference. Interference. In last lecture, we discussed explanation of reflection and refraction by Huygens principle. And in today's lecture, we discuss interference. Interference occurs in any type of waves. So, any type of waves. Light wave, sound wave, matter wave, any type of wave shows interference phenomena. If you take a light as a wave, then and then we can explain interference. If it is a ray, you cannot explain interference. Okay? To explain interference, we need superposition principle. Superposition principle. That is already discussed in last year, that is in 11th. Don't worry. थोड़ी झलक आपी दઉં છું. What is that superposition principle? Suppose this is the point in the space somewhere. It may be particle or point. Then there are so many waves are passing. Suppose I say 2 waves, maybe more than 2 also. So wave is passing over here. Because of this wave, this particle is to be displaced by 3 centimeter up. I say y1. And one more wave is also passing over here. And because of the displacement is supposed to be 5 centimeter down. But both the waves are passing at a given point. Then what will happen to this particle, or what is happening to that point? If it is matter wave, the displacement you can show of the particle itself. And if it is electromagnetic, then just you can see the oscillation of electric and magnetic field vectors. Due to this two, it will displace y1 plus y2. It is one dimension, so I just take without vector notation, otherwise I have to use vector. So it is in one dimension, so 2 centimeter down. You can say this is plus j, this is minus j. So if you add it, then you will get minus j. So what is the meaning of that? When at a given point 2 or more than waves are passing, the displacement that of particle will be equal to vector sum of the displacement that would occur due to each wave. So in short, you can say that displacement is equal to vector sum of the displacement due to each wave. Okay, you have to do vector addition. Suppose one in x direction, other in y direction, then you have to take I and j both. And you can understand now. To explain this interference, First, I take the example of wave propagates in the water. So suppose this is the field with the water. It is water tank. And these are the two vertical rods are oscillating up and down perpendicular to the surface of the water with same speed going up, down, up, down, up, down. Because of that, you will get the wave as I have shown three waves. And if you consider one point P here, then both the wave will reach at the same time because S1P is equal to S2P. So both waves will reach at the same time at point P. So what happens to this particle P? This is oscillating, so I say y1 is equal to a cos omega t. I can sin omega t also depending on initial position. And y2 is equal to a cos omega t. Both have same periodic time, same frequency, same amplitude, everything same. અહીંયા પહોંચે ત્યારે actually I have to consider distance also, પણ અહીંયા આગળનો પાર્ટિકલ અહીંયા પહોંચે એનું ઓસિલેશન થાય છે according to this અને આ વેવનું according to this. જો અહીંયા હોય, if this wave is here, તો તમે યાદ કરો kx મારે પ્લસ માઇનસ કરવું પડે, પણ I am p પોઈન્ટ પાસે પહોંચ્યા પછીની વાત કરીએ છીએ આપણે. So what is happening to p? So y is equal to y1 plus y2. So I get 2a cos omega t. Okay. So this particle which oscillate with amplitude 2a. So here amplitude is equal to 2a. What was the amplitude? A. So amplitude becomes double. Since both are in same phase, બંને સેમ ફેઝમાં છે, so it adds. તો a માંથી 2a થયું ને, we know the intensity જે છે, intensity is proportional to amplitude square છે. So we can say that intensity here is 4 times initial intensity because 4a square, 2 square એટલે 4 થશે. So new intensity will be 4 times than the initial intensity. આ point પાસે intensity એટલી થશે. Okay. So this is the intensity at point P. If S1P equal to S2P, તો આવું થશે. Same thing here, you can see here. This S1 and S2 here only, and I taken P like this. So this wave is generated, 1 wave, 2 wave, 3.5, 1, 2, 3.5. It means path is same. So here also S1P is equal to S2P. So this is same situation actually. Intensity will be 4 times I0. But now what happens to this point Q? Again we check it. So this is one wave, this is second wave, and this is third wave. So S1P is equal to 3 lambda and S2P from here to here is equal to 1, 2, 3 and 4 lambda. And therefore S2P minus S1P is equal to lambda. So this wave has to travel more distance compared to the wave emitted from S1. Wave emitted from S2 has to travel more distance. How much? Lambda compared to the wave emitted from S1. So if I take wave emitted from here is y1 is equal to a cos omega t and emitted from S2 is Y2 is equal to A cos omega t. Then what is happening when reaching over here? Phase here because of this will be more equivalent to the distance lambda, equivalent to distance lambda, or you can say this is behind, this is behind. So I can add 2 pi here or I can subtract 2 pi here, meaning is same. જો આને હું એટલું કહું તો મારે એને 2 pi જેટલું મારે શું કરવું પાછળ રાખવું પડશે. સમજમાં આવ્યું? And other, if I say A cos omega t here, then I have to add 2 pi because distance is lambda. In text it is given 2 lambdas. They have 4 pi લખેલું છે. So don't worry, you can take anyone. So you know that this is nothing but A cos 2 omega 2 t minus 2 pi is, you can say that cos minus 2 pi minus omega t. And cos minus theta is equal to cos theta, so I can write A cos omega t. Again meaning is same. So y1 and y2 both are same. See, y1 and y2 both same. અને જેવું થઈ ગયું. બે સેમ ફેઝમાં જ ભેગા થયા એમ બી કહી શકાય. 2 pi જેટલો ફેઝ ડિફરન્સ છે પણ એક સાથે બે ભેગા થયા એવું કઈ લાગે આપણને. So again intensity will be, you can calculate y is equal to y1 plus y2. So you will get y1 plus y2. So it is first, like similar to the first case, 2a cos omega t, and therefore intensity at Q is also 4 times intensity 0. Here intensity at P. અહીંયા P ની પાસે વાત હતી. Understood? Third case, I take point R. So what is the distance covered? So 1, 2, 3, 4, 5, 6, 7, 8, 8.5. And here 1, 2, 3, 4, 5 and 6. So S2P, I take same only, S2P minus S1P is equal to 8.5 and 6, okay, 2.5 lambda, but it is negative. S2P is less than the S1P. Understood? So I write y1 is equal to A cos omega t and y2 is equal to A cos omega t at the origin. But જ્યારે અહીંયા પહોંચે ત્યારે શું થશે? This has more phase compared to this one because it reached earlier. એટલે આની phase વધારે હશે. કેટલી? Equivalent 2.5 lambda. Equivalent 2.5 lambda. Lambda means 2 pi. So 2.5 lambda કેટલા થશે? 5 pi. યાદ છે ને? Lambda means corresponding to 2 pi. So for 2.5 lambda how much? Okay, 5 pi. સમજમાં આવ્યું? You will get 5 pi. So whether you add here or you can subtract, meaning is same. I'm going to add કરું છું. So A cos omega t plus 5 pi. So this is become minus A cos omega t because it is in third quadrant. In third quadrant cos is negative. યાદ કરી લો પાછું. This is in third quadrant. So in third quadrant cos is negative. So it is minus A cos omega t. So what is happening now? y1 plus y2 is how much? So y1 plus y2 is equal to 0. So intensity is 0. And therefore intensity at R equal to 0. This is case 3. This is case 2. And this is case 1. Understood? So intensity at R0. Why? Okay, now phase difference is 5 pi. તો આના પરથી આપણે આગળ ડિસ્કશન એવું કરી શકીએ, if S2P minus S1P is equal to lambda or 2 lambda, 0 3 lambda, then phase difference કેટલો થશે? Phase difference is whether 0 or 2 pi or 4 pi and so on. Then we get intensity is equal to 4I0. આપણે આવું થયું. Now I write in proper way. If this is called path difference, બે રસ્તા વચ્ચેનો difference. If path difference is equal to n lambda, or this is called phase difference. Difference is equal to 2n pi, where n is equal to 0, 1, 2 and so on. Then intensity is maximum. So intensity maximum આવ્યું. This point gives maximum intensity. Okay, so this is called constructive interference. Interference, પછી ડેફિનેશન આપણે નહોતી કીધી, તમને શબ્દ રહી ગયો છે. Interference means phenomena due to superposition of waves. Okay. And આગળની વાત કરું તો જો આવું ન હોત, okay, if path difference is equal to n plus half lambda, or phase difference is equal to lambda is corresponding to 2 pi, તો શું કે n plus half 2 pi, અથવા તો અમે આમ કહી શકાય કે 2n plus 1 pi, n starting from 0, 1 and so on. Then intensity અહીંયા કેસમાં 0 થશે, because both have same amplitude. Otherwise minimum મારે use કરવાનો. શું થાય? Minimum. Intensity is minimum, called destructive interference. Destructive interference. Called destructive interference. હવે તમને થાય કે મેં મિનિમમ વર્ડ છે આપણે 0 કેમ નહીં લખ્યું? સમજો. What we have discussed in that phase, amplitude is same. એટલે કે તમે જો એક વેવ આમ આવે છે અને બે વેવ આવી રીતે ભેગા થયા, ક્રેશ ટુ ક્રેશ, તો ડબલ થઈ જશે. So we get 4I0. Final wave is this much. But if out of phase, so phase difference is pi or 3 pi, like this. If I put 0 and pi, I put 1, 3 pi, then like this. Here amplitude, same amplitude down. One is great, other is tough. So you will get 0. But if this is 3 and this is 2, then 3 plus 2 is 5. Then at that time it is not 4I0. It will be something different. And 5 and 2, then 2. 3 and 2, then you will get 1. તો આ કેસની અંદર જો આવું થતું હોય, એક 1 and this is 2, we get 4I0. But જો આવું હોત, this is and this is more than that, then it is not 4I0. It will be different, but it will maximum તો કઈ જગ્યાએ? Same thing is here. If it is down, then we can say it is 0. And if it is down here, then it is 1, corresponding to 1. So it is not 0, but it is minimum. So be careful. We don't use the word 4 times always. We say maximum. And when it is destructive, it is minimum. Is it clear? સમજો ખાસ પોઈન્ટને ફરીવાર તમે રિકોલ કરજો, ફરીવાર ચલાવજો કેસેટ, એટલે તમને વધારે આઈડિયા આવશે. આ બધી વાતો કરી. we talk about wave propagates in the water surface. So where you get the maximum, it remains maximum only. અહીંયા minimum 0 મળો, 0 રહેવાનું છે. This is maximum, so it remains maximum only. Repel તમને જોવા મળશે, બે સોર્સ હશે, you will get maximum displacement. You can see that pattern because whatever your source is not changing their frequency. એનો ફેઝ એમનો જ રહેવાનો છે. તો અહીંયા જો જ્યાં લેમ્ડા રહેવાનું છે, it remains permanently lambda only. If you read lambda, then it remains path difference lambda. પણ જો આવું થતું હોય, મન ફાવે એમ, એક બહુ સ્પીડમાં ચાલતું હોય, એક ધીમે ધીમે ચાલતું હોય, એક બહુ ફાસ્ટ ચાલતું હોય, બીજું ધીમું ધીમે ચાલતું હોય. એમ્પ્લિટ્યુડની વાત નથી કરતો. I am talking about the frequency. I am talking about the periodic time. So phase difference will change continuously. So we are not getting permanently maximum displacement at Q and 0 at R. કારણ બદલાય કરશે. તો એવું થશે, ક્યારેક R પાસે પણ મેક્સિમમ થઈ જાય, Q પાસે 0 થઈ જશે. તો if phase difference remains constant between the two source or between the sources. આપણે બે સોર્સની વાત કરીએ. two sources. એક સાથે ઉપર નીચે જવાની જરૂર નથી, એક આમ જાય તોય ચાલશે, પણ ફેઝ ડિફરન્સ બદલાવો જોઈએ નહીં. two sources, then this source is called coherent source. Very important one, coherent source. કોહેરન્ટ સોર્સ એક હોય જ નહીં. કોહેરન્ટ સોર્સ એક કરતા વધારે ત્યારે જ વાત આવવાની છે. એક સોર્સ તો ગમે તે હોઈ શકે. કોહેરન્ટ સોર્સ સેમ ફ્રીક્વન્સી એની બદલાય નહીં, પીરિયોડિક ટાઈમ ના બદલાય. સો ફેઝ રિમેન્સ કોન્સ્ટન્ટ. If phase remains constant, phase difference also remains constant. Not necessarily be 0. અહીંયા 0 આપણે વાત કરી હતી, પણ 0 ન હોય તોય વાંધો નથી. જો phase difference ના બદલાય તો એને coherent કહેવાય. And to see stationary pattern, we need coherent source. Don't be confused. Interference is occurring for any type of the source, but stationary pattern can be seen only and only if they are coherent. Interference થવાની શરત નથી, interference સ્ટેશનરી થવાની શરત છે. નહીં તો શું થાય, એક જ પોઈન્ટ પાસે અલગ અલગ સમયે ફેઝ બદલાય એટલે એમ્પ્લિટ્યુડ બદલાય, તો આપણને જોવા ન મળે. બને ક્યાં તો વિખાઈ જાય, Is it clear? Now we will switch over to light wave. આપણે હવે લાઇટ વેવ તરફ આપણે ફોકસ થઈ જવાના છીએ. બરાબર છે? ઇલેક્ટ્રોમેગ્નેટિક વેવ, અને એનું આપણે ડિસ્કશન હવે કરવાનું થાય છે. Before switching over to light wave, one thing I want to say here. See, here wave has amplitude A, here also amplitude is small a and A amplitude. When it reaches to P, naturally amplitude will little bit decrease because wave attenuate. But we have not considered that part. Second thing, here distance covered by the wave is same, so whatever the attenuation is also same. આપણે attenuation ધ્યાનમાં લેવાનું નથી, પણ હોય તો સેમ જ હતું. But in this case, this wave has traveled less distance compared to this distance. તો અહીંયા attenuation વધારે થાય compared to that one. પણ આપણે એમ બી કહી શકીએ S1 S2 is very close. S1 S2 is very very less compared to S1P and S2P. આ ડિસ્કશન આપણે એના માટે કરેલું છે. This both are very close compared to the point we have taken. Okay. તો એમ્પ્લિટ્યુડ જે અહીંયા છે એ જ એમ્પ્લિટ્યુડ આપણે અહીંયા લીધો છે, નહીંતર રિયાલિટીમાં થોડો ઓછો હોય એ આપણને ખબર જ છે, તેમ છતાં કેલ્ક્યુલેશનમાં લીધું નથી. બી કેરફુલ. નાઉ I take a random point. So we discussed when phase difference is 0 or 2 pi, pi, whatever. But if phase difference is maybe anyone, not necessarily completely pi or 2 pi or 3 pi only, integer ma na પણ હોય, then how we can determine the intensity? So I take one randomly point 1 G, where path difference is not integer multiple or wavelength of half integer multiple of wavelength, anything. So હું કહી શકું when it reach to that point, y is equal to, I say suppose a cos omega t and y2 is equal to a cos omega t plus phi. Suppose phase difference is pi, it is not pi or not 2 pi. હોય તો આપણે કંઈ વાંધો નથી પાછો. તો હવે ત્યાં ઇન્ટેન્સિટી કેટલી થશે? We derive one general formula. So intensity, as we have superposition principle, y1 plus y2, and we put the value equation cos omega t plus a cos omega t plus phi. We use trigonometry, so a is the common, so cos omega t plus cos omega t plus phi. We have one formula cos a plus b is equal to 2 cos a plus b by 2 omega t plus phi by 2, then cos a minus b by 2, so omega t minus phi by 2. આ ફોર્મ્યુલા છે આપણી. Cos a plus cos b is equal to 2 cos a plus b by 2 into cos a minus b by 2. Understood? We use this, so we get 2a cos, I write first this one, this is cancel, minus phi, cos minus theta to cos theta, so not necessary to write the negative sign, I just write phi by 2, and cos 2 omega t plus phi by 2. So this is now amplitude, and this shows it oscillates, it performs simple harmonic motion. Okay. Okay. So intensity is equal to, we can say that intensity proportional to 4a square cos square phi by 2. So we can say that I0 cos square phi by 2. So total intensity total depends on phi by 2. So if phi by 2 is equal to 0 or pi or 2 pi and so on. So what is phi? Okay, 0, 2 pi 4 pi. Okay, I equal to 4I0 means constructive. Okay, same thing we write for minima also. So intensity will be 0. क्या रहे? 5/2 is equal to 0 or pi/2 or 3 pi/2 and so on. तो આપણું શું થશે? આ 0, phi equal to 0 or not 0, sorry, not 0. 0 is then 1. 0 is not there. So pi, 3 pi and so on. Then we get I is equal to 0. It is called destructive interference. Okay. So this is the condition for destructive interference in terms of phase. We already discussed actually, and this is the condition for constructive interference. In between, कोई भी value हो, we put the value of phi, you get the intensity. Suppose I say phi is equal to pi/3. So you put this value over here. So I is equal to 4I0 cos square pi/6. 5/3 5/6 5/2 છે ને. So 4I0 cos pi/6 is √3/2 and then square. So you will get 4I0 3/4. Okay, so you will get 3I0. So totally depends on phase difference. If these forces are not coherent, then what will happen? At a given point, phase is continuously changing. Phase is continuously changing, so you cannot write this one, but I have to write average I is equal to 4I0 average cos square pi/2. And if I is continuously changing, if you calculate this average value of cos square, you will get half. You can do it. You have to integrate from 0 to 2 pi cos square pi/2 d phi and 1 upon this 2 pi. So you will get half. Half 1 plus cos 2 theta, you can do it. So this is 2I0. So if it is not it is not coherent, these sources are not coherent, then at a point you will get average effect. Ani be I0, ani be I0, it becomes 2I0. Here also it is 2. So everywhere you will get 2I0. But if it is coherent source, if they are coherent source, then intensity 1.0, other 0.4I0. So when you see this pattern, or when you see this steady interference, energy redistributed. 4I0 કે એનર્જી ક્યાંથી જનરેટ નથી થઈ, બટ જ્યાં ડિસ્ટ્રક્ટિવ તેની એનર્જી ત્યાં જતી રહેશે. So it is a redistribution of the energy. You can say it is redistribution of the energy. If non-coherent, then everywhere 2I, because even I0 is other 2I0, so it becomes 2I0, simple. પણ જ્યારે coherent હશે તો કોઈ જગ્યાએ 4I0 થઈ જાય, કોઈ જગ્યાએ 0 થઈ જાય. So average remains same only. Okay, so this is the thing for the for interference. Now we will switch over for light wave. Okay, હવે light wave માં આપણે જતા રહીશું.